Have you ever thought about a future where the organ transplant waitlist just doesn't exist? A future where, if you need a new heart or a new kidney, one could be printed for you, on demand, using your very own cells? Well, that's not science fiction anymore. Today, we're going to dive into the incredible reality of 3D bioprinting and the massive quest to solve one of the biggest challenges in all of medicine.
But to really get why this technology is such a game changer, we have to start with a number. Just one number, 18.
That's how many people, on average, die every single day, just in the United States, because a life-saving organ didn't get to them in time. The reality is, the demand for organs is just so much higher than the supply. It's a truly heartbreaking situation.
So, what if we could just sidestep that whole waitlist problem? What if, instead of waiting and hoping for a donor, we could literally print a brand new heart, or a kidney, or a liver, perfectly tailored to the patient? Well, this is the incredible promise of 3D bioprinting, and believe me, it is changing everything.
You see, this desperate shortage of organs is the fire that's fueling this entire field. It's pushed scientists and engineers to think way outside the box, and what they've come up with is this amazing blend of biology, engineering, and material science.
So what in the world is 3D bioprinting? Well, think about your printer at home. But instead of squirting ink on a paper, a bioprinter uses this amazing stuff called bioink. It's basically a special gel packed with living cells and all the nutrients they need to grow. The printer then carefully lays this bioink down one super thin layer at a time to literally build a living three-dimensional piece of tissue from scratch.
And you know, this technology didn't just pop up overnight. The idea's been building for decades. It really all started back in '84 with the invention of basic 3D printing. By the '90s, researchers were already tinkering with inkjet printers to see if they could handle biological stuff. The early 2000s, that's when we saw the first real success in printing living cells, and from there, it just took off. Now the focus is on these incredibly complex problems, like figuring out how to print tissues that have their own built-in blood vessel.
And this isn't just some far-off dream. Bioprinting is already being used today. We're talking custom skin grafts for burn victims, new cartilage to repair joints, and one of the coolest things, scientists are printing organ-on-a-chip models. These are tiny, working versions of human organs that could completely change how we test new drugs, maybe even ending the need for animal testing one.
All right, so how do they actually do it? How do you go from a file on a computer to a living, breathing piece of biology? Well, the whole process, as complex as it is, can really be broken down into three main stages.
The whole journey has a really clear path. It starts with a digital blueprint, then moves into the physical printing stage, and it all finishes with this super important phase where the new tissue is basically nurtured into existence. Let's walk through each step.
Okay, so first up is pre-bioprinting. This is where a CT or MRI scan is used to create a perfect 3D digital model of, say, the patient's own kidney. Then the special bioink is mixed up with the right kind of cells. Next, you have the bioprinting itself, where the machine gets to work meticulously following that digital map. But it doesn't stop there. The last and maybe the most critical step is post-bioprinting. This is where the freshly printed structure is put into a special device called a bioreactor, where it can mature and grow into a fully functional tissue.
Now, during that printing phase, scientists have a few different methods they can use. It's not one size fits all. Some techniques, like inkjet, are really fast and affordable. Others, like extrusion, can handle much thicker materials. And then you have laser-assisted printing, which gives you incredible detail, but it's pretty pricey. Really, the method they choose all depends on what they're trying to build. A simple patch of skin needs something very different than a complex piece of bone.
Now, I know this all sounds pretty straightforward, but let's be real. Making this work for a full-sized human organ is one of the hardest things anyone in medicine is trying to do right now. The challenges are just massive, and frankly, overcoming them is where all the really cool innovation is happening.
For starters, you have to keep the cells alive. I mean, the printing process can be really rough on them. Then you have the bioink itself. It needs to be easy to print with, but it also has to be a place where cells can be happy and healthy. We also still struggle to print with enough detail to create the tiniest parts of an organ, and that leads to probably the biggest hurdle of them all, vascularization. You've got to build in a network of blood vessels. Without it, you can't get oxygen and nutrients deep inside a big piece of tissue, and it'll just die.
So that's the million-dollar question, isn't it? You can print the most beautiful, complex structure, but if you can't keep it alive, if you can't feed it, it's useless. It's just a fancy, lifeless scaffold. So, how are scientists even beginning to solve this problem?
This is where we get to the absolute cutting edge of the field. This is where researchers are coming up with these brilliant solutions to take these printed tissues and actually grow them into real working organs.
The answer, in a word, is the bioreactor. And what is that? Well, you can think of it as an artificial body. It's a high-tech device that creates the perfect little world for a printed tissue to grow up in. It pumps in nutrients, it clears out waste, and it gives the cells all the right signals they need to start working together and organize into a real organ.
And these bioreactors are so much more than just fancy containers. They have to actively mimic what the body does. For example, to grow a heart, the bioreactor has to provide gentle stretching and tiny electrical pulses to teach the heart cells how to beat together. For a lung, it has to simulate the rhythm of breathing. Each organ gets its own custom-built nursery. It's incredible.
And the pace of progress here is just staggering. We're seeing brand new bioinks that are way better at keeping cells alive. Scientists are now using AI to design better organ structures and to perfect the printing process. And maybe the most exciting thing of all is multi-material printing, the ability to print with different types of cells at the same time, which gets us so much closer to building something that looks and acts like a real organ.
The progress has been so fast that we're really at this profound turning point. The question isn't if we can print organs anymore, it's when. When is this going to be a real option for patients? And that brings up even bigger questions, right? Who's going to get access to this kind of technology? How do we make sure it's used ethically and fairly? The science is moving at lightning speed, and pretty soon, we as a society are going to have to come up with the answers.